Alright guys, so today we will be discussing about breakout strategy in Python. So this will be like the second part to what we did before with the algorithmic trading in Python, which is like a beginning course. So now we'll be doing more complicated strategies. We'll be back testing some of these complicated strategies. So this one is just a pure breakout strategy, and at the end of the video you should be able to get returns like these. This is for Apple. So percentage returns and also the largest profit and the largest loss. We can get it for Tesla. The largest profit is 413. The largest loss is minus 26%, and the investment return, if we put $1,000, it'll be 15,000. We can also do MSFT, which is again a pretty large return. So we'll start from the basics on how to plot them, and then how to get the charts done, and then how to backtest this properly, and also at the end we will be creating the function which helps you save this function and let run different variables, so different investment amounts and all those things, so you'll get a better idea. So let's start. So you all know how to create the Jupyter notebook and everything. So if you don't know, our first video, the algorithmic trading video, will be a great start for you guys. I'll leave the link in the description, also on the top right hand corner. So you must first watch that video so you get a basic understanding. So once you watch that video, then the rest will be pretty simple. So let's first start with creating the libraries. So just to import Y-Finance, so that's where we download our codes, and then the pandas, obviously. These are all the libraries that we will be using. So I've discussed this in detail in that video, but we'll just code this anyways so you guys understand the flow of it. Seaborn. We'll just change the name as well, so I'm going to give it Donchian Breakout, and obviously it's a YouTube video, so YouTube. So okay, this header file has been loaded, so I'm just going to download one stock data, so it'll be yf.download. Let's do Apple first. So Apple, and let's do the stocks. So let's see what we get. So again, we've got lots of information from 1980. We've got the open, high, low, close, adjusting close, and the volume. So we'll only be working with the close. So I'm just going to create a new data frame. So just with the close data. So df stocks, and then just the close. And let's see what df gives us, and there you go. So we've got the data frame with just the closed data in it. So this is a typical Donchian breakout strategy. So before that, let's just plot the graph, see what the graph represents. So it's pretty simple. df.plot fixed size equals 12,8. So by the way, the entire code is available in the description if you want to download it. So title equals closing price, and then let's give font size equals 12. Obviously plt.show. So there you go, there's the graph of the Apple. So now let's do the important thing in creating the breakout strategy. So I'm going to do a 20-day breakout initially, just to give an example. So I'm going to give period high equals 20. So df highest equals df close, so it's capital close, make sure everything is perfect, dot rolling. So we need the highest of the past 20 days, right? So that's rolling. We can use a rolling function, which is the same thing we did for our moving averages before. So window equals obviously this one here, period high. So that'll give us the 20-day rolling period, and then we need to find the maximum of that 20 day, because we're getting the highest value of that past 20 days. So that will be high dot max function, So max function, and then dot shift 1. The reason why I'm doing shift 1 is that we need to exclude the present day. So it's the 20 days of the past 20 days. So dot shift. So by default it's shift 1 period. If you give 2 periods, it'll be like 2 periods ago. So I'm just going to give nothing. So basically we get that. So I'm now just going to run that. I'm just going to put this one here just to be on the safe side of it. So yeah, so we basically got the DF highest as well. So obviously the first 20 periods won't exist, and the rest ones will exist. So far so good. So now let's just plot the graph just to see whether we have, so we'll just go into like tiny details, so just the 2020 graph just to see, so we can get to see how perfect this graph that we have created is. So there you go. So we got the high line here. So the reason why I put shift 1 is otherwise it will be on top, like it won't cross that line. So we need to get the previous day's high. So there you go. A beautiful graph here. That's a 2020 graph. So you need to type plt.show to remove this thing here. It's not really a necessity, but there you go. So that's a 2020 graph. Now let's declare the buying condition. So the buying condition will be df buy will buy when the closing price is obviously higher than that in this green line, right? So np.where, so df close is greater. So we need to make sure that the close of yesterday is greater. So there's a reason why we're doing it yesterday, because when we confirm that yesterday's close is higher than the previous day high, we're entering a trade today. So if you actually put the close of today, then we'll get a look ahead bias. So we need to make sure that the condition is met yesterday so that we can make a trade today. So for that, again, we're going to use the shift function. So shift is greater than df bracket highest dot shift, and if that's true, then the signal generated, so we'll give it 1, else it's 0. So hopefully there won't be any errors. If there is errors, it's good, so you learn why the error is happening, where the errors is happening, and you can learn how I adjust the things. So I'm going to run it. I'm going to call the df. So basically you can see certain areas the df has been created. So for example, here the highest was 166, but the close was 168, so hence a buy signal was generated. Again, here the highest was 168, but the close was 170.21. Again, a buy signal was generated the next day. So if that makes any sense, so we need to generate the buy signal the next day so that we don't have a look ahead bias. Otherwise the trade will be, the results will be kind of flawed. So we've got the buy signal, so now we need the sell signal. So for that we need to declare the selling condition as well. So I'm going to give this period high. Again, we're going to give this period low. So when am I going to exit the trade? So I'm going to do the exit as 40 now. So what I'm going to do is I'm going to give period sell equals 40. And then we're going to do the lowest one. So df of lowest, it's basically exactly the same as this one here, except that instead of max we do, guess what, min. And then instead of so just give it period low here instead of sell, so that it goes in perfect. So dot max instead of here will be dot min. So we're going to run that. So that's, there you go. So you're going to run that again. So basically we've got the DF highest and the DF lowest. About these warnings, forget about it, doesn't matter. It'll keep on popping up. So now we've got DF lowest as well. So again, we need to declare the sell condition, which is again, we just take this, going to copy paste that. Going to change the different things. df cell is df for close dot shift is less than lowest, and we basically got the cell condition as well. So let's run the df. So there you go. So again, we've got the buy signal and we have got the sell signal as well. So far so good. Now let's just see the specific time period. So we've actually got the df buy and df sell. So when did this trades happen? So I just want to see, I don't want to see here where 0,0,0,0 is happening now. I just want to see when the buy transaction took place and the sell transaction took place. So what I could do is I could do df dot buy equal to 1, or which is this one here, df dot sell equal to 1. So I'm just going to give brackets here just to make it neat. So whenever that condition is met in df, so in the entire data frame, so df, so we put a bracket there, and then we put a bracket there, and we're going to store that into df trades. So df underscore trades. Then I'm going to just display that df underscore trades. So there you go. So these are the specific days where these sell conditions and these buy conditions have been called. So you can see many of the days has been removed. So at least we know where the signal has been generated. So the other problem is that there can be multiple signal generators. For example, these are like consecutive signals being generated. So we can avoid that completely, right? So we need to do only the days where there is a buy one and the sell one, a buy one and a sell one, rather than initially a sell one. So what we could do is we can use the diff function. So diff basically takes previous days and the this days and subtracts it and gives you a value. So that value can be +1, -1. So in this case, we want a +1. So I'll explain to you while we code. When you get the results, you'll get to know what it's all about. So df underscore trades, which is basically this data frame, and then we're going to do the square bracket. I'm just going to copy paste entire of this, so it'll be much easier for us to pull this off. So instead of here, this will be df underscore trades. So here, and this will be df underscore trades dot buy equal to 1. So again, dot buy dot diff. So use a diff function there, and similarly df underscore trades dot sell dot diff equal to 1. Now I'm going to store this to trade. So now you will see what I'm talking about. So as you can see here, we've got a buy one here and then the sell one here. Buy one here, sell one there. Buy one here, sell one there. And that just keeps on going like multiple times. So basically we've got 179 rows. So technically 2 of these is like one trade. So we entered here and then we exited this date. So we entered here again and we exited this date. So if I give -1 here, it completely changes the whole, you see what you get? Completely different outlook. So the difference is basically the difference between the previous day's buy and the present day's buy. Similarly, the sell is a previous day sell and the present day sell. So whenever we have that condition, we're going to plot it, and there we go. So we've got the trade right there. So if there is any confusion, or if there is any concern, or if there are even corrections, feel free to comment it, because at the end of the day, we're all trying to learn, we're all trying to develop our knowledge. So there are things that I'm not thorough about, but you might be thorough about. So there might be Python traders out there or Python coders out there who knows far better than me, but feel free to comment down if you feel that any of these things are out of line. So now I'm just going to do the DF graph just to be, just to show the entire content we have there. So we need to figure out which are the days where the buying has taken place, which are the days where the selling has taken place. And I also want to know how many buys and how many sells have taken place. I also want to know if there's an open position. If there's an open position, then I can give it 1, and if there's a non-open position, then I can give it 0 or a false. So let's create some information like that. So we're going to create some empty arrays. So by dates, by underscore dates equals just an empty bracket, and then sell underscore dates equals another empty bracket, and then buys equals another empty bracket, sells equals another empty bracket, and open position, initially I'm going to give it false. So that's it. So we've decided these are the things we want to use. So now I'm going to do a for loop. So the basic for loop was discussed before, I think, in the algorithmic trading video, but anyways, I'll discuss it anyway. So for I in range length of df, so basically it takes all the 10,409, it basically loops through that. So that's the length of the df. So length of df will be this one here. So the range will be for I will be 0 to 10,409. So the loop is going to repeat that many times. So again, the colon. So again, the next line. So if, so now I'm going to do an if condition. So if we have a buy trade, okay. So if df dot buy dot I lock, and then we're going to do I. So it goes through the loop. So it goes to df dot buy dot 1 2 3 4 5, and then if open position equals false. So initially the open position equals false, right? Equal to false. Then we need to initiate a trade. So that means we can append this. So you see that buys. So we need to enter the data there. So buys. Why is this red? Buys. Dot append and I, so that the number I will now be entered into the array of buys. So basically it checks whether we have a buy order, and then it enters the row of that buys number into that buys array. So you got buys, and then we need to, obviously we need to say that open position now is basically true. Position is true. Okay, so far so good. Now buy dates, so we need to figure out the buy dates as well. So buy dates, again we need to fill in that information. Buy dates is equal to df dot I lock I dot name. So basically it gives out which specific date the trade took place. So we just give it dot name. So there you go. So basically we've got the if condition for the buy signal. Now we need to do for the sell signal as well. So I'm going to completely come out of this if statement and then do elif df dot sell dot I lock I. So if there's a sell condition, then we need to check if we have an open position. If you don't have an open position, there's a completely different story. So if we have an open position, so open pause, so you can actually do open pause equals true, or you can just give open pause. So what basically it checks is, like default, it's like it's true. If I just leave it just like that, otherwise I could just give equal to true as well. So if open pause sells dot append, so I need to sell, so I'm going to give that information. So this sells number get the I just stores into the cells array. So cells dot append I, then open position now is false because now we've just sold a position, so our trade is over. So open pause equals false. So remember, this is only a buy only, long only strategy. There's no short strategy. We're entering and we're exiting, that's it. But exiting is basically a sell. So false, and then we need to do the sell dates as well. So I'm just going to copy this entire thing. Going to paste that there, and instead of buy dates, I'm going to give it sell dates. So the loop hopefully has gone through. So now let's just see how many buys and how many sells have we got. So let's just give len of buys. So I'm just going to give print len of buys, and then print len of sells. So we've got 90 buys and 89 sells. So that's a bit of a red flag, and that's because you see the last day 23. So I think it's better to go this trade data frame. You see the 23rd, we've got actually a trade on. We've got a buy, and we haven't got a sell condition yet. So that's a big, it's not a big problem. That's the reason why we have got 90 buy trades and 89 only sell trades. So I need to remove that. So I need to get a standard statement so I can get rid of those kind of situations, so our calculation of returns will be more perfect. So what I'm going to do is I'm going to do if condition again. So if len of buys is greater than len of sells, then buys dot pop minus 1. So what it does is removes that last element of that array. And then we also want to remove the buy dates as well. So buy dates dot pop minus 1. So now let's print the length of the buys, see what we get. Beautiful. Now we've got 89 buys and 89 sells. So that problem is completely sorted. So now let's do this whole a data frame where we enter the buy date and also the sell date and also the buy price and also the sell price. So we need to create this data frame so that it'll be easy for us to calculate the results, the returns, and all those other things. So I'm just going to give it check, just because I can't think of any name as of now. So pd.dataframe. So I'm going to give it a bracket and then the curly ones there. So I'm going to give the name buy date. So buy date and then colon will obviously be this buy date. So I'm just going to copy that, paste that there, and then comma sell date. Colon paste. We just need to change this buy to sell. So now I need the buy price and the sell price as well. So again, comma buy price. So buy price is basically the close value of that specific buy date. So that's a pretty simple thing to do. So all we need to do is df.loc. So that basically locates that specific buy date. So buy underscore dates. So when that buy dates get filled into that df.loc, we just need to give the close value for that. So the close value, and I'm just going to do values. So that'll give us the values of that. And also we need the sell price as well. So sell price, sorry about that scrolling thing, it's quite annoying, so I'm just going to enter it here. So sell price colon df.loc sell underscore dates dot close dot values. So hopefully everything is sorted here, and there's a bracket as well. So hopefully there's no errors. If there is errors, we'll figure it out then. So I'm just gonna run this as well. CHECK. So there you go. So we've got the buy date, we've got the sell date, we've got the buy price, and we've got the sell price. Beautiful. So we've got a total of 88. So basically we've got 89. So that's the first one is 0. So we've got 89 trades, which is pretty decent. So now let's check the P&L percentage of each trade. So that's pretty simple. We just have to subtract buy price minus sell price divided by the buy price, and basically we have got the percentage return. So we're going to do it inside this data frame itself. So check PNL percent, PNL underscore percent equals check dot sell price minus check dot buy price divided by check dot buy price. That should give us the percentage. Just to check again. So there you go, we've got the PNL percentage as well. So basically 3.2% loss there, 14.9% loss there, and then you know the big ones here. So regardless, so we've got the overall percentage. So we can also calculate the cumulative percentage. So that's basically cumulative product of it. So when we do that, the last column will tell us how much is our total percentage returns on that investment. So I'm going to do that as well. I'm going to do it separately as well for us easier calculation. But regardless, I'm going to do it right now. So check of cumulative PNL percent equals check of PNL underscore pers, which is this one here, plus 1 and dot cum product, which is basically subtracting the cumulative. So this is a function of that. So if you want a clear definition of the function, you can always Google it, but basically it multiplies these percentages and gives us the final value of that. So again, I'm going to do check, and this is our final return on our investment, but we'll come back to that. We'll check that in a bit. Total trades equals length of PNL underscore pers. So that'll give us the total trades. So PNL pers is not defined. So why is PNL pers not defined? Oh yeah, so it's basically check.PNL pers. So total trades. Total trades is 89, which we already knew. So regardless, I'm going to do a thing. I'm going to create a profits array just so that we don't mess about with this data frame, because we've got this data frame pretty clean. I don't want to mess around with that data frame. So I'm just going to do profits, create another column, another array, sorry. So basically it's df.log check.selldates dot close dot values. So what it basically does is the check dot sell dates, you see these sell dates, so that dates get sent to the data frame df, and then we get the value of the close. So remember we calculated the PNL percentage. It's pretty much the same thing, but slightly this one here, the same way we did the buy price and the sell price. So close dot values minus df dot log check dot buy date. It's a good thing to, there are other ways to calculate it, but I just want you to go to the complicated stuff, so this might prove useful to you in some other situation. So I'm just going to do profits. So there we go, we've got a list of the arrays of all the profits generated. So we now got the total trades, and now let's work from this data, this information that we've got. So let's do I equals 0. The reason why I want you to do I is equal to 0 is because we've already declared I before. So I need to find out which one are the profit trades and which one are the loss trades. So then we can calculate the win ratio, right? We can calculate the profit trade ratio. So I'm going to just give I is equal to 0 so you realize why. So I'm going to give it profit underscore trades to find out how many of the trades are profitable. So profit underscore trades is equal to length. So again, I for I in profit, so basically the entire array here in profits, if I is greater than 0. So if I is greater than 0, then that I will be stored to profit trade. So then we'll know how much is the profit trades. So then we can actually get the profit trades percentage. So I'm just going to copy this, profit trades percentage equals profit trades, profit underscore trades divided by total trades so total trades, there you go, there's a total trades there, so there's no underscore there. Profit trades divided by into 100, so into trades into, apologies for that, did I just swear? So there is no len. Oh yeah, so basically we need a square bracket here and there as well. So there you go. So let's find out the, let's just print it. So let's print number of profit trades equal to curly brackets, now dot format profit trades. So this is just basic printing of stuff. So you know, we've discussed this in our previous beginner course, and again we'll also print the win ratio equal to curly brackets dot format profit trades percentage. So number of profit trade is 48, win ratio is 53%. That is not that bad. So this is much more of a trend following, momentum following kind of a strategy. So it really doesn't matter what the, you know, the win ratio is. The win ratio should be even 33%, and still we should be able to find out the total. We should be able to have a profitable strategy. So now let's create another array, just like we created the profits. Let's create profits percentage as well. So I'm just going to copy paste the same thing. So profits underscore percentage. Again, like I said before, the reason why creating a separate array is simply because I don't want to mess up with that data frame. It might be useful later on. So copy, and then the by date, going to enter there. So it's an unmatched somewhere, so basically we don't need this stuff here, should go through. So that's a profits percentage. Let's see the average profit. So we've got the profits percentage all stored here, so let's calculate the average profit. So the average profit equals to profit percentage dot mean, right? So we'll just do dot mean mean asterisk 100. So the reason why I'm doing all these things is that you can ruthlessly analyze the strategy efficiently. So the average profit is 14.99. That's not bad. That's really not bad. So now let's create the list of the profit, so then we can calculate the net returns. So I'm going to create the list underscore profits, which is basically what I'm going to do is just this cumulative whatever. So it's not really a big deal. It's the same thing that we did before. So list profits equals profits underscore pairs profits underscore pairs plus 1. So we do the bracket here, dot cum product, and that should give us the list of profits. So now let's calculate the net. So I'm just going to call the array as well. So the final value here, that's our final net returns percentage. We need to find the percentage, right? So I'm just going to give net returns percentage. So net returns underscore pairs equals this one here, list of profits. So I need to call this last value. So all I need to do is this one here, list of profits, and then that of -1. So this will give us this value here. and I need to calculate the percentage returns, right? So -1 into 100 will give me the percentage returns of this strategy. So net underscore returns underscore pers. So this is our returns for this strategy, 233,288 percentage returns. That's our returns to this strategy, which is kind of huge, but always be careful when you do these kind of things. So now let's do the largest percentage loss as well. So basically, again, that's pretty simple. So pairs underscore profits dot min will give us the largest, largest loss, sorry. So pairs, profits underscore pairs, sorry, profits underscore pairs dot min. So that's 56.7%. It's pretty high, to be honest with you, but still it's expected in a trend following strategy. So now let's do the maximum, the largest return. So again, we've got 220%, which is pretty decent. So we're actually getting a big win, largest win to largest loss ratio is very high, which is quite good. So now let's do, like, let's say you invest $1,000. What do you get in return at the end, right? So that is one thing we need to calculate as well. So let's say initial investment equals 1,000. So the investment return will be equal to initial investment asterisk. So we got the percentage profits percentage, sorry, again, I keep on making these mistakes. Profits underscore percentage +1 dot com product, which is again the same thing. We just need to copy paste the other one, but I'm just going to go through this one. So percentage profit +1 dot com product, and then we need the last one, right? The last column, last row column of that last value. So that -1 thing, if we do it again. So there you go. So if we invest $1,000, we will be getting $2,333,889 at the end of the day if you use the strategy from day one. So this is pretty cool, but this has been many years. So we're looking from 1981. So this was before I was even born. So at the time when I was not born, if I had done this strategy, yeah, I'd have made a heck of a lot of money. But that's a completely different story. So far so good. So now what I want to do is I want to create a function. So this is just for Apple. I can't be bothered to do the entirety of this thing every single time. So I would like to create a function which serves the purpose for me. So let me create a function. So I've discussed on how to create a function again in the algorithmic trading basic video. Again, the link is in the description, but I'll go through that all over again so you guys get an idea. So basically, again, I'm going to do def test of strategy. Again, I'm going to need to have the name of the stock, so which is basically stock, and then buy days. So how many days should the breakout be? So this one we did 20, right? So we also did 40 as a sell date, so I can mix that one up as well. So I'm going to give that. I'm also going to give the amount of money that I fancy investing. So I'll give all these values, and I want to know what my return will be. So again, I'm going to give it a column, and I'm going to give data equals yf.download stock. So basically, when I feel Apple or Tesla in there, it automatically downloads that stuff there. And then I'm going to do df. So I just want the close value. So data dot close dot to underscore frame to 2 underscore frame. So now everything is pretty much copy paste, but I'm going to walk with you. So first one is this period high. So this period high will be the buy days. Okay. And then the sell days will be the period low. That's the only major thing you need to be changing in the entirety of this code. Then obviously we have that array and that for loop, right? So I'm just going to copy paste entire of these things, the buy dates, comma, sell dates. Just give it a space, so so make sure it's all inside this function. So when you copy paste, that can happen a lot. This copy pasting will create problems, so just be careful. There you go, there's our first problem there. So that will be tab, tab there, tab there, tab there, tab there. And then elif will also be a tab, tab there, tab there. Yeah, so far so good. And obviously we need to pop out that unnecessary if there's an additional buy signal, right? So now let's copy paste the check and the percentage profit and all those other things. So now we've actually got all these values, so let's return these things. So basically return, so print, so I'm gonna give some names, and also I'm gonna attach all these largest loss and largest profit. I've actually fast forwarded it for your convenience. So basically it's return percentage, which is the net return percentage, which we've got here. And then we've also got investment return, which is the return invest here. And then we've got the largest loss, which is the largest loss here. And then we've got the largest profit, which is the format of largest profit here. So hopefully everything goes in line, this whole function. I'm just gonna run it, hopefully there's no any errors. Yeah, it's gone well. So I'm just gonna do this test strategy here, just copy this, and I'm gonna do I equals 0 just to be on the safe side. Yeah, and then I'm gonna paste it. So what do we want? So we just did Apple, right? So we'll just double check whether Apple works, so whether this function has done well. So 1000. Okay, we have got an error, percentage profit is not defined. So this is in line 42, largest loss, large loss. So that's basically profits percentage. Again, I made mistakes there. Profits percentage, and then here, good thing I have figured it out. Let's do it, fingers crossed on this one. Yay, so we've got it. So 233,289, which is exactly what we got before. Yeah, we also rounded the numbers to make it look more neat, because round of 3. And then we've got the investment return, which is 2,333,000 if we had a $1,000 fund. Largest loss is 56% and largest profit is 220%. So now let's try it on Tesla. So Tesla looks okay. Let's try Twitter. Is a simple name, TWTR? I'm not sure. Yeah, so again, Tesla, it's not that great, but return percentage is only 110.3, but the largest loss 20%, largest profit is 98. Investment return for a $1,000 fund is 2,102. What are the other companies that I'm thinking of? Coca-Cola, KO. I have a feeling it might not perform that well in Coca-Cola. Well, it actually did perform quite well, but the largest profit is quite small. It's a bit of a red flag for me. But anyways, hopefully you guys got an idea on how to code the Donchian Breakout strategy. The code is in the description, but try messing around with these days. So for example, I could do 40 day, let's see what we get. Could possibly get like a loss or something. Well, it still gives a return percentage, which shows why breakout strategy is quite good, because you know, not only is it, I'm having two edges here. One, I'm breaking out to the upside, and the second edge being that this is a long only strategy. So that's possibly the reason why I have a minor edge in this. But in any strategy, it doesn't matter if it's a breakout strategy or a false breakout strategy, you need to diversify as much as possible. So don't take the strategy, this 20 days breakout and 40-day breakout, and then go mental on it on every single stock that you know, but diversify across 10, 20 stocks. Don't be obsessed with on just one single stock, because you might not have a trade. Like you saw, there were many, we only had 89 trades since 1981 on this Apple. So we need to diversify as much as possible in as much as stocks as possible. And I've also coded this exact same strategy in in Tradingview Pinescript, so that's there in the video description as well. So if you just want to code it in Tradingview, you can go ahead, but note that the Tradingview results will be different from the results in the Python, because Yahoo Finance, they're so good with their data, they've got like multiple decimal points, which on the other hand, Tradingview, it'll be like 2 decimal points, it'll just be 166.55. so on the long run, the results will be different because the data feed is different. So you go to different data feeds, you get a completely different results, but it'll at the end of the day be positive. Like I think this strategy on the Tradingview Pinescript was like 300 something percentage profit, as compared to here it was like 200 something percentage profit. And also I think the minor change I did in the Tradingview Pinescript was, instead of the close I was looking at the high. So if it breaks the high of the previous day, so what do you get? So basically that's the other thing. I forgot to put in the drawdown as well in the strategy, but to calculate the drawdown, it's there in the previous video, the algorithmic trading full tutorial in Python. So you can actually put that in the function here and actually calculate the drawdowns as well. So hope you like this video. Have a great day.